Okay, this is part 3 of the video for this this PDF, this handout, 13.3 Arithmetic and Geometric Series. And we're going to focus this video on the Geometric Series. So I'm going to scroll down to page 2, or I guess I should say flip to the back of my worksheet, depending on how you printed it out. Now, Geometric Series, of course, you're multiplying every time, and the giveaway, if you look at an explicit formula, the giveaway is that you actually have an exponential function right here, which denotes repeated multiplication for every term. So that's what makes it geometric. And we're just going to give away the formula. I'm not going to derive it for you, but there it is. Right? It's the first term times 1 minus r to the nth over 1 minus r. I will point out these do not cancel, right? Because of the exponent n, right? That's on the r, not on the 1 minus r. So you can't cancel those out, although it looks like they almost should cancel out, but it doesn't. Okay. Well, what does that mean? Well, let's write down what we have here as far as this series. The first term, you plug it, just like anything else, you plug in n equals 1. N equals 1 would give you 1,000 times a half, or 500. And then each term you keep multiplying by a half, so you get 250. Let me just move this down to give myself a little bit of room, if you don't mind. 250, 125, and it just keeps going till the 15th term, which of course is going to be really small. Not even sure what the 15th term is. You can find it with a calculator, but you keep having it, those numbers get small pretty quick. So, what do I need to know? I need to know the first term, which is 500. I need to know the common ratio. That's the 1/2. That's what you keep multiplying by every time. And I need to know n. N is 15, which is right here. It's the number of terms. And this is just a plug-in. I'd like to tell you guys this is more complicated. It's really not, right? You're going to plug in 500. 1 minus r is 1/2, and the power is to the 15th. Note the 15 does not go inside the parentheses. It's 1/2 to the 15th, not 1 minus 1/2 to the 15th. So it's got to make that distinction. So I guess if you're typing this in on your TI-84, you need to make sure you kind of group the top and group the bottom, right? If you just kind of type it in without those parentheses, you're going to mess something up. And of course, you're going to hit the divide key where the fraction bar is. If you do that, you get, I'm going to round it off here, you get about 999.97. And guess what? Maybe a topic for a future date, but that's if you added up the first 15 terms. If you went anywhere beyond that, you're not going to get over 1,000. You keep, as 1/2 to a power increases, you keep adding up smaller and smaller numbers. So, if you did the 16th power, you'd probably get 999.975. It wouldn't get much bigger at all. Let's look at one more example. Number 8. It's already written out for us. Let's just list a couple things. We know the first term, we know the common ratio, and we know the number of terms is 12. And to be perfectly honest, you could really just write out, if you had to, you could just write out all 12 terms and add them up. But as long as we have this fun little formula, let's use it. A sub 1 is 1. 1 minus r here is 2. N is 12. And you're dividing by 1 minus r, so 1 minus 2. Again, my suggestion, if you're going to type this in as is, group the top and the bottom before you hit the divide key. And finally, you get exactly 4095. There we go. Okay, and let's look at just 2 word problems, okay? So here's Tom. He can't pay his rent on time. For each day that he is late, he pays $10 in late fees the first day, 15 the second, 20 the third. So his late fees are going to look like this. It'll be 10 plus 15 plus 20, so on and so forth. So the first thing you got to determine if it's arithmetic or geometric. Of course, it's arithmetic because I'm adding every time. I'm adding by 5. So the common difference is 5. And they want to know if he's 18 days late. So he gets charged 18 of these late fees. So we want to know, hey, what does this add up to, right? And we have this, we have this formula. You can use either one. I'm going to use the second formula for the arithmetic, right? It's n. I'm going to double that first term plus the common difference times n minus 1. And I'm dividing the whole thing by 2, right? So 18 days, we double the first term, so we're going to double 10. Oops. The common difference here is 5. N minus 1 is 17. Make it look better, put that in parentheses. And divide by 2. So all together, he has $945 in late fees. So what's his total bill? Well, his total bill, I guess, he still has to pay his rent. So it's going to be $1,200. He's got to tack on that $945. He owes $2,145. So that's an example of an arithmetic series as a word problem. And then guess what? We'll do one that's geometric. Kind of a fun one here. Here's a kid, he gets, what does he get? 1 cent on the first day, 2 cents on the second, and then 4 cents, and then 8, so on and so forth. Doesn't seem like much, but if you keep doubling, those numbers will get pretty big. Notice I did it in terms of cents. I didn't want to deal with decimal points. I didn't want to say 0.01 and 0.02. So let's look at what does he get on the 31st day. Well, that's not a series. That's a sequence. So it's a sub 31, which is the first term times the common ratio to the n minus 1. N minus 1 would be 30, right? It's basically 2 to the 30th, right? If you kind of look at it, it's 2 to the 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And if you look at this, and then of course move the decimal point. I'm gonna do this and then move the decimal point. It's 10,737,418 and 24 cents. So if the number of pennies would be the decimal point 2 more to the right. So just a ridiculous number. That's just what he gets on the 31st day. Of course, if you wanted to add up the first 31 days, that's the sum. And that'll be even a bigger number, right? It's the first term, and then 1 minus the common difference to the nth power over 1 minus r. And if you do that, it's over 21 million. Not a bad allowance if you can get it, right? There it is right there. Okay, so a couple examples of some geometric series.